Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on July 23, 2025, so just about 2 weeks ago. This paper introduces a new model that helps robots better understand and act on instructions, outperforming an expert system aided by GPT-4o by 29%. The paper is titled InstructVLA, Vision Language Action Instruction Tuning from Understanding to Manipulation, and as we'll see, the results are really impressive. This work addresses a major challenge with what are called vision language action models, which is that they often lose their general reasoning abilities when trained for specific physical tasks. Alright, so this figure gives us a great overview of how the authors tackle this. The core idea is a new training paradigm they call vision language action instruction tuning. This process is designed to unify language understanding with action generation. For example, in the bottom left, the model shows it can understand a complex common sense scene, and then use reasoning to connect a question like which fruit is sourest to a physical action. And the chart in the top left demonstrates that this approach successfully preserves general reasoning skills while still excelling at manipulation tasks. So let's look at the architecture itself. The process is broken into 3 main steps. First, the pre-trained vision language model on the left handles the reasoning, generating a language response. Then, a crucial component called the mixture of experts adaptation comes into play. This is a clever design that allows the model to dynamically switch between reasoning and planning and action. It generates what's called a latent action, which is like an abstract plan. Finally, the action expert on the right translates that plan into precise robot movements. Building on that architecture, a huge part of this is the specialized vision language action instruction tuning data shown here. The process starts with a basic instruction from an original dataset. Then, to improve what they call embodied scene understanding, they add detailed scenario captions and question-answer pairs. Next, for better instruction following and planning, they use techniques like command rewriting, for instance, changing put knife to place the cutting tool, and context creation, which provides a larger goal for the robot to reason about. So, moving to the results, this table really drives home the point about retaining general knowledge. You can see with OpenVLA, a model trained for manipulation, the scores on these multimodal understanding benchmarks are just 0 across the board, a classic case of catastrophic forgetting. But if we look at the author's model, which they called generalist here at the bottom, it not only performs well, but it even exceeds its own base model, Eagle 2, on several key benchmarks. This shows the new training method really works. This table then shifts the focus to robotic manipulation. Looking at the expert version of the model, which is highly specialized, it achieves a 59.9% average score, a massive 30% improvement over the spatial VLA baseline. But what's really impressive is that the generalist model, the one that retained all that world knowledge, also excels here. On the challenging, simpler ENV Instruct benchmark, it soundly beats a fine-tuned OpenVLA, even when getting help from GPT-4o. This really shows the model's dual prowess. So to wrap things up, the key takeaway here is that InstructVLA successfully bridges the gap between understanding and action. It creates a robot that can both reason about the world and precisely manipulate it, overcoming the common issue of catastrophic forgetting. That's it.